All right, we are now recording, and let me say again, for Jesus' benefit, I put an announcement out there about the NASA's Community College Aerospace Scholars Program. It's a great program. Several students from Lawson have participated in the past and they've all had a blast doing it. It's a lot of fun. You learn a lot. It's a great opportunity. Then they sent a second email this morning saying they may not have included all the information they needed, but I think there's enough on there you can get to it. I will try to send the copy of that new email, but I've been in class all morning, so I haven't had a chance. So anyway, if you are interested, pursue it. That first announcement that I sent, you'll notice here it says announcements 4 posted. I don't know if you can see this screen or not. 4 total. One of those is that NASA Community College Aerospace Scholars Program. Okay, so look at that. They have some links on there you can go to and get the information you need to participate. But the event is this evening. I believe it's 7 till 8. I think it may be 6 till 7. It's something like that. And on that email, it's not real clear, but they start with Pacific time, Mountain time, Central time, and Eastern time. And I believe the Pacific starts at 5, the Mountains at 6, we would be at 7, and Eastern would be at 8. So I believe it's 7 to 8. It's the same session. It just starts at different times in different zones, but it's the same session. All right. Any questions, issues, concerns, either concerning that or anything else? Okay. All right, let me get the whiteboard set up. And we will go from there. Okay. Now I've got some maneuvering around, so hang with me for a moment if you can. If you can't, hang on anyway. I've got to move this taskbar here to the bottom part of my screen. I've got to scoot Kira over to the right part, and James. And I've got to scoot this other taskbar as far right and up as I can, and then scoot the whiteboard, which is probably all you can see, but it's a bit more involved than that for me, up and to the left as far as possible. Okay, gives me the maximum amount of white space. So hopefully Jesus will be coming in soon. So watch for him if you can see him. Okay. Last time, we're in Chapter 1, Systems of Linear Equations, 1.3, Applications of Systems of Linear Equations, and that's on page 31. We had started example 7, and we had gotten down to the point of the following equations. Now, I'm not going to redraw it. Hopefully you've got it, or you can look at it before. Here's our circuit diagram, okay? And we're using Kirchhoff's laws. We have the junction laws. You see the 4 junctions there, 1 at the bottom left, I believe it is, 2 is the bottom right, 3 is the top left, and 4 is the top right. I'm looking at everything backwards here, so I think I'm saying it right. Have 3 power supplies in there. I'm having trouble reading them. 10 volts on the far right, left, I'm sorry. 17 at the top in the middle, and at the far right it looks like 14 volt. And then you got a number of resistors. I see 1, 2, 3, 4, 5 resistors there. Okay. Now you also have a number of currents. Okay. The current that goes through that first resistor there, they're calling current 1. And then the one through the second one's current 2, third one current 3, fourth one's current 4, fifth one's current 5. I think there's 6 currents there because there's 6 resistors and 6 currents. That's the picture. If you have your notes from last time and drew it out, there it is. here are the equations we wound up with from that. And again, remember, the junction law, Kirchhoff's junction law, said the sum of the currents coming into a junction has to be 0. So here are the first of those equations. I1, now they do capital I's. I usually like to do little I. This is so aggravating. I1 minus I2, now this may not be how I wrote it before, but I think it is, plus I3, then leave space for I4, 5, and 6, that's equal to 0. Because this total current coming in has to equal to total current going out. The minus sign handles that. The second junction gives us I1 minus I2 again, plus I4 this time. And the total current coming and going from a circuit has to equal to a junction has to equal 0. The third one gave us I3 minus I5 plus I6 is equal to 0. And at the fourth junction, you have I4 minus I5 plus I6 has to equal 0. Now, the loop laws, and we're just going through the 3 interior loops. I don't know if you noticed that when I had the book up there. You could do outer loops, you could do anything, but they're the 3 loops, and they give it the direction so that it makes sense with the batteries. So your 10 volt, the positive is down, so the current should go in that direction. The 17, the positives to the right, so that's going in that direction. And here on the 14, the positive is up, so the loop is going in that direction. Hey, if you got the loop going in the wrong direction, it'll just give you negatives, but it'll all work out. Okay, so let's take those 3 loops and add up the voltages in those loops. A battery is a plus and the resistors are minuses. So that gives you, so let's put the pluses on the right, and then your resistors will all be positive because they're on the opposite side. So the first one that we have there gives you 2I2, 2I1, I don't know where I got the 2 from, plus 4I2, and that's equal to 10. 2 resistors in that loop. I can't write with this pen. That's 10. Your second loop gives you 4I2 plus I3 plus 2I4 plus 2I5 it's hard to stay online here. That's equal to 17. There's your 17 volt power supply, battery, whatever. And on that last one we have 2I5 plus 4I6 is equal to 14. Okay. Now, there's our equations. We need to get that into a matrix form. I hope I've got everything right. This is a lot of space. I'm going to try to condense it a little bit because very soon I've got to erase those equations. So let me make sure I got it right. I'm going to try to shrink it up some. So that's going to be a 1, a -1, a 1, and a 0. I hope I haven't shrunk too much. The next one's going to be a 1, a -1, a 0. Oh, I need zeros in here too. That's 4. I have to wait until that silly thing. That's 4, 5, and 6. So those are zeros there. Okay, so this is a 1 here, a 0 here, a 0 there, and a 0 there. Okay, this is a 0. That sort of looks like a 4. Okay, the third one is a 0, a 0, a 1, a 0, a -1, a 1, and a 0. Okay, fourth one is 0, 0, 0, 1, -1, 1, and 0. Okay, now your loop law ones are a 2, a 4, a 0, 0, 0, 0, 10. Next one's a 0, a 4, a 1, a 2, a 2, a 0, and a 17. And the last one I'm going to try to squeeze in here is a 0, a 0, a 0, a 0, a 2. Now, stop right here, okay? I wish I'd have stopped sooner. I'm going to make this a 1, 2, 7. It usually helps to have as small a number as possible. And I'm going to do the same thing for this one right here. This should be a 2, 4, 5. I'm sorry, it is a 2, 4, 7, 10. I'm going to make it a 1, 2, 5. 1, 2, and 5. Yuck! So 1, 2, and 5. No reason to haul around bigger numbers than you have to. Keep it as simple as you can. This one down here can't do anything with it because it has even and odd, so can't do anything with that one. Alright, that's my matrix. I hope I have it right now. So what I'm going to have to do, unfortunately, is erase my equations. Or at least these down here. So hopefully you've got them written down and you can correct me if I've got something wrong. Please correct me if I've got something wrong. I'll probably erase the rest of them later, but for right now, let's just get rid of those. Alright, go back to my draw mechanism here, and let's see what we want to do. Okay, what we want, 1 in the upper left, 0's below. So what we'll do here is do row 2 minus row 1 is the new row 2. You could do it either way, or -1 times row 1 plus, okay, so that would be -1, okay, write down the first row, that's the one you're using. 1, -1, 1, 0, 0, 0, 0. Okay. New second row will be a 0, 0, -1, 1, 0, 0, 0. Now y'all correct me. I'm doing this fast. I hope y'all are doing it with me. Okay. Now, you already got a 0 here, so I'm going to write it down. 0, 0, 1, 0, minus 1, 1, and 0. We've already got a 0 there, so let's write that row down. 0, 0, 0, 1, negative 1, 1, 0. Alright, in this one we want that 1 to become a 0, so we'll do the same thing as before. Row, whatever that is, row 5 minus row 1. Okay, it'll be the new row 5. So that's going to be a 0. And I think that's going to be a 3. It's 2 minus a minus 1. And then that's going to be a minus 1. And it looks like 3 zeros in a row. And a 5. Alright. And then the last 2 rows have leading zeros, so let's write those down. 0, 4, 1, 2. Oh, y'all help me out there. Yeah, that's a 2. A 2, because these things write so weirdly. 0 and 17. And the last one just barely squeezes in here as a 0, 0, 0, 0, 1, 2, 7. Okay. Now, so we got a leading 1 here and zeros below it. That's good. Oh no. How did this occur? Yuck. You know how the book gets away with this? Use a graphing utility or a software program or Gauss-Jordan elimination, solve the systems to obtain. And they don't show a single step in doing that. The thing that really irks me here is the fact that we're going to introduce some fractions here. I hope I've done everything right so far, but the fractions will go away in time. That's not always guaranteed, but they do in this case because I look at their answers and they are. So I think what I want next is this row to go up here, and that becomes my new second row, plus I'm also having to divide by 4. Okay? So that's going to be 1 minus 1, 1 with 4 zeros. 1, 2, 3, 4. Okay. My new second row is going to be this one divided by 4. So that's going to be a 0, 1. And I don't know if I want to write it as fractions or decimal. Let me write it as fractions. 1/4, 1/2, 1/2, 0, and 17/4. Boo hiss. Okay. And then the rest of the rows, it's not going to matter too much, but I think I will do one thing. I'll keep this row as my third row here because that has what I want. A 0, 0, 1, 0, minus 1, 1, 0. But I need to put this row in somewhere, so I'll put it next. 0, 0, minus 1, 1, 0, 0, 0. And then I'll put in the next row 0, 0, 0. I don't know what made that noise. Let me see if maybe Jesus is coming in. Nope, I don't see him. So let's just keep going. I don't know. These things ding all the time. I think that would left me off at a 1, -1, 1, and 0. And then the next one is the one with the 3. So it says 0, 3. Wait. Now I got to do it, I guess. -1, then 3 zeros, and a 5. And then I move this row up, so the last row is 0, 0, 0, 0, 1, 2, and 7, I think. Okay. Now I hope I still have 7 rows and 7 columns. But I know we're going to lose a row. Let's see if we got it. 1, 2, 3. Yeah, 7 rows, 7 columns. All right, what's next? We got a 1 here, zeros below it. We got a 1 here. Now the question is, do we want zeros above it and do Gauss-Jordan, or do we do Gaussian elimination? They suggest Gauss-Jordan, so let's do it. That's going to mess up things significantly there, but I think we can live with them. Okay, I don't know if I'm going to fit everything in here or not, but I'm going to try. So what we're going to do to get a 0 here, we're going to add row 2 to row 1. Okay, so let me write down row 2. 0, 1, 1/4, 1/2, 1/2, 0, and 17/4. This is a big boo hiss here. Adding those two together, you get a 1 here and a 0 there. That's the easy part. This gives you a 5/4. This gives you a 1/2. This gives you a 1/2. This gives you a 0. And this gives you a 17/4. That just messed up everything, didn't it? All right. And you got zeros below this, right here, down to this one. So I've got to write all those others in there. And this is what makes linear algebra so tough sometimes, especially if you're doing it by hand. You're just writing the same thing over and over again. 0, 0, 1, 0, -1, 1, 0, 0, 0, -1, 1, 1, 0, 0, 0, 0, 0, 1, -1. Yuck! That's a -1 there, folks. I don't know why it did that. 1 and 0. Now, this is the one we're changing now. -3 times row 2 plus row, whatever it is, 6, I believe it is. Okay. So, that will give you a 0 here. That's good. This will give you -3 plus 3 is 0. -3/4 minus 4/4 is -7/4. I'm hating this. -3/2, so that's going to be a -3/2. This drives me nuts. Okay. -3 that's another minus 3 halves. It won't draw a minus sign. Okay. And then this will be a 0, thank goodness. And this will be a 5. Okay. Last row we'll leave 0, 0, 0, 0, 1, 2, and 7. Alright, I know this feels like an exercise in futility, and if I come up making a stupid mistake somewhere, that's exactly what it will be. Hopefully y'all are doing it with me and keeping me from making stupid mistakes. Are you? Please say yes. Are we okay so far? Have I done anything that seems suspicious, out of hand, out of reality? Okay. Out of pocket, wherever it's out of. Okay. So, the next matrix up here will be, let's go back here and see what we've got. If I can find it, there it is. Leading 1, 0 is below it. Leading 1, 0 is above and below it. Leading 1 here, that's why I moved it here. We want zeros above it and we want zeros below it. We've got some work to do, folks. Okay, so the first one here, to get that to be a 0, it's minus 5/4 row 3 and add that to row 1. Okay, let's do it. First one would be a 1. The second one is a 0. The third one is a 0. Minus 5/4 times this is minus 5/4 plus 5/4 is 0. Next one's going to be a 1/2. Okay. The next one's going to be a 5/4 plus 2/4. That'll be 7/4. I believe. Yeah. The next one's going to be a minus 5/4. I hope I'm in the right place, am I? 1, 2, 3, 4, 5. I should be on number 6. Yeah, that's right. Minus 5/4. That's why it's better on one long sheet. Everything is fairly close to each other. We're not here. Oh, and now the bad one. Minus 5/4 times 17/4 is going to be, oh my goodness, a minus 85/16. Someone do the math and make sure I did it right. I'm going to add to that 4 times 17, 78/16. I think that's right. And that's going to be a minus 7/16. This is not looking good, people. I don't know if it's because I've made a mistake or it's just nasty. It's nasty. Okay. Now, the next down here, next here, we're going to want this 1/4 to become a 0, so that's going to be minus 1/4, row 3. Yuck! This is so aggravating. Plus row 2. Okay, so that gives me a 0, a 1, I hope a 0. Yeah, minus 1/4 plus that. And this gives me a 1/2. And this will be a positive 1/4 plus 1/2 is 3/4. And this gives me minus 1/4. That's 1, 2, 3, 4, 5, 6. Yeah, we're right so far. And that gives me a 17/4 still. Oh, what a pain. Okay. Now, the next row is pretty easy. This one stays the same, so let's write it down. 0, 0, 1, 0, minus 1, 1, and 0. And the next row, we're going to add row 3 to row 4. Row 3 plus row 4. Okay, and that gives me a 0, a 0, and a 0. And a 1. That's sort of encouraging. A minus 1, a 1, and a 0. Okay. Next row, we're going to do 7/4. Row 3. Oh, I skipped this one. This one, we've got just what we want now, so let's write it down. 0, 0, 0, 1, minus 1, 1, and 0. Now, hopefully you notice there, these two rows are exactly the same. So basically, I'm going to get rid of this row right here. I'm not going to use it anymore, so let me just erase that row, and that will ease up some of my crowdedness. Not much, but a little bit. This row is next going to become a row of all zeros. It would go at the bottom. I'm not going to bother writing it down. Okay? Now, so what was my row? This one down here, that's the one I want here. 7/4 row 3 plus row, I don't know whether to call it row 4 or row 5. It's row 5 here, but it will be row 4 in the future. It's going to be the new row 4. Let's just put it that way. So that's going to be a 0 here, a 0 there, and a 0 there. Okay. 7/4 row 3. Okay. Where is my, there it is. That will be a 0. So that's a minus 3/2 still. Minus 3/2. 7/4 row 3, that would be minus 7/4 minus 6/4 is minus 14/4. Not minus 13/4. Okay. This is so hard to write. And the next is going to be a 7/4 times 1. It would be 7/4 plus 0, so that's just going to be a 7/4. And then finally we got a 7/4 times 0 plus 5, so that's just going to be 5. Alright, the last row can be written as is. 0, 0, 0, 0, 1, 2, 7. Now, starting here, it's almost going to be, there's no going back again. because once I erase this, I bet you I'm not going to be able to go back and trace where any error came from, if there is an error. Hopefully you've not let me made any errors, didn't you? I can't swear to that. I don't know how this looks at home, but it's sort of cool here to watch that thing just zooming across the screen and kind of erasing things. Okay. So quick review. We gotta, wherever my cursor is, there it is. 1 here, 0 is below, 1 here, 0 is above and below, 1 here, 0 is above and below, 1 here, which is excellent. So what we want to do is to get this 1/2 to become a 0. So it's going to be minus 1/2 row 4, add that to row 1. I don't have much room to put here. Minus 1/2 row 4 and add that to row 1. Okay. Okay, let's see if we can do that. That will give us a 1 here, a 0 there, a 0 there, and minus 1/4, 1/2 times this will be minus 1/2 plus 1/2 is a 0. And minus 1/2 of this will be a plus 1/2, or 2/4, plus 2/4 plus 7/4 is 9/4, I hope. This is really not looking good. Here we have a minus 1/2 times a 1 is minus 1/2, or minus 2/4. That will be minus 7/4, I hope. Minus 7/4. And that took off my 4 there. How many more do we have to go here? That's 1, 2, 3, 4, 5, 6. One more. Minus 1/2 times this will be a minus 17/8, which will be a minus 34/8, no, minus 34/16, minus 7, that's a minus 41/16. These are terrible numbers. Minus 41/16. This is getting worse and worse. I can't believe this is going to come out good anywhere. Okay, next we want this 1/2 to become a 0. So we're going to do minus 1/2 row 4 plus row 2. Minus 1/2 row 4 plus row 2. Okay, and that gives us a 0 here, a 1 here, a 0 here, a 0 there. Now minus 1/2 of a minus 1 is plus 1/2, or plus 2/4, and I think that's a 3/4. That'll be 5/4. Again, these numbers are getting worse and worse. Then you'll have a minus, I hope I'm on the right row here. I don't think I am. Okay, I think that was all right. This is a minus 2/4, minus 1/4 is minus 3/4. Okay, and then a 17/4. All right, next This is already good, so we're just going to write that row down. 0, 0, 1, 0, minus 1, 1, and 0. Alright, we're using that row, so we'll write it down. 0, 0, 0, 1, minus 1, 1, 0. And this one we want to become a 0, so we're going to 3 halves, row 4. This drives me nuts. 3 halves, row 4. I can't stand this thing. Plus row 5, I think it is, and that's going to be the new row 5. So that's going to be a 0, a 0, a 0, and 3 halves, yeah, that's a 0, and 3 halves times minus 1 is minus 3 halves, which is minus 6 fourths, minus 13 fourths is minus 19 fourths. These are awful numbers. That's 3 halves, which is 6 fourths, plus 7 fourths is 13 fourths. And, ew, yuck. No, that's fine. That's just going to be a 5 then. All right. And then the last one I think is fine the way it is. That's a 0, a 0, a 0, a 0, a 1, a 2, and a 7. All right. So we got a 1 here, 0 is below it, 1 here, 0 is above and below, 1 here, 0 is above and below, 1 here, 0 is above and below. Oh my. Okay. What I'm going to do is switch these two rows. Get this one up here and get that ugly thing down there. Okay. Are y'all anywhere near saying, okay, we get the general idea, let's just end it? Are y'all okay with that? Or do you want to see it drawn out to its terrible conclusion, which probably is going to be, I messed up something somewhere. What do you think? Want to go on and do one more? Let me know. You see how to do this. Certainly if you have a calculator, that will be doing better. If you have a graphing calculator that you can feed this stuff in, that's even better. They're tedious to feed in, but you can do it. Or computer programs, you still got to enter all the data, and it's just real tedious to do, but then let it run its course. Okay? Do you want to see any more, or you get the idea? You get it? Okay. Let's just say we got to the answer. I'm not sure it's coming that way, but let's say we did, and you get I1 is equal to 1 amp, I2, I'm just taking this from the book, is equal to 2 amps, I3 is equal to 1 amp, I4 is equal to 1 amp. Boy, they made this sort of simple, didn't they? That's why I couldn't believe what we were doing. I5 is equal to 3 amps, and I6 is equal to 2 amps. Let's just see if maybe this was coming out right. The easiest one to check, I think, is this one right down here. This is I5 right there. So that would be 3 plus 4 is 7. Oh my goodness, it does look like it's coming out right. Let's see if this makes sense. This is I3 would be 1, minus 3 would be a negative 2 plus 2. That's coming out right. This one would be I4, 1, minus 3 plus 2. That's coming out right. My word, we may be on it. This may be that those fractions are going to disappear at some point, but I sure don't want to have to go through what it's going to take for that to happen. But it could happen. Okay? It sure looks like at least those three that are easy to plug in, they look like they are coming out correctly. So we got 1, 2, 3, 4. 4 of the currents are correct according to those. Let's just check this one just for funsies. This one won't be so awfully bad. Minus 19/4 times I5. Ooh, that's going to be minus 57/4 plus 26/4. So minus 57 plus 26. That comes out. Oh, it doesn't look good, does it? That comes up minus. No, that doesn't look good. There is an error in there somewhere. Okay, it looks like. Yeah, because that would be a minus 31/4. That's not 5. So yeah, there's an error in there somewhere. Let's leave it. Okay, good vote there. So anyway, that finishes finally. Whew, what a note to end on. 1.3. Homework exercises in 1.3. Now you may or may not do, just depends on what you're interested in, the polynomials. We sort of skip through those because those really take the time. So any of the odds 1 through 11, if you're interested in doing those, do them. That all at back of the book and at Calc Chat. 13's at Calc Chat. 15's at Calc Chat. And again, only do those if you want to. 17 or 19 are both at Calc Chat. Again, it's only if you want to do those. But beginning with 21, do either 21 or 23. Those are networks. Those should be at Calc Chat. And then circuitry, either 25 or 27. Those are circuits, like we were just doing. Now, ones like we have it done, but they explain how to do it, that would be 29. It should be at Calc Chat if you want to pursue that one. If you're going into a field where temperatures might be important to you, and I'm trying to think where that would be, probably mechanical engineering, possibly electrical. I don't think civil would be so strong that way. Chemical might, so if you're going into a field where temperatures are going to be an issue, you may want to do 29. Partial fraction decomposition, either 31 or 33. We did those when we were in calculus. Maybe we'll still do those. I can't remember where you are in your calculus, but you should be able to do those. 35 is an eigenvalue type thing, which if any of you are, well, in this course, we're going to hit those again. So you may want to try that one. 37 is another calculus problem. It's sort of like the first few. You can do that if you'd like. And then 39 is a guided proof, only if you want to do that. It should be at Calc Chat. And 41 is another polynomial type. Now, if that hasn't given you enough exercises to do, there are review exercises for the whole chapter. Either one or any of the odds 1 through 5, they should be at Calc Chat. 7 should be at Calc Chat. Any of the odds 9 through 19 should be at Calc Chat. 21 should be at Calc Chat. Either 23 or 25 should be at Calc Chat. 27 or 29 should be there. Any of the odds 31 to 39 should be there. 39 might be a little bit of a bear. And then any of the odds 41 to 45 should be there. 47 or 49 should be there. Excuse me. Any of the odds 51 through 57 should be there. True false 59 should be there. 61 should be there. 63 partial fraction decomposition again should be in the back. Polynomial curve fitting, if you're interested, 65 should be in the back. 67 and or I'd say any of the odds 67 or 69. If you want to try those, you could. 71 network analysis, and that's it. They do have a project at the end. If you want to look at that, you certainly can. We are now ready for chapter 2. Now, here's the thing, folks. I think I've already put test 1 out there. Is that correct? I believe I put it on Blackboard message. Okay. Now, since I've been fiddling around with these new templates they have us doing, I may in the future put your test under your assessments. So far we haven't had any assessments, but I could put them there, and therefore you could check them there, you could get them there and put them back there if you wanted to, or you could send them back through a Blackboard message or attach it to an email. I don't care. Any way you want to do it. You can take pictures. When you take a picture, be careful, don't get your shadow, or get the light so it comes in at the side, like with a lamp or something, rather than overhead, because when you hold your camera over the thing you're taking a picture of, you create a big shadow if you've got an overhead light. So if you can have lamps, have the lights coming in obliquely from the side, that gives you a better shot. Or if you can do a PDF, that's great too. Okay. I've had some students just type out answers. Now, the problem with that is I can't see your work. Then it's either right or wrong, and you may not be able to get as much partial credit as if I can see your answers. So, however you want to get it to me, it's on Blackboard message right now. I think in the future I'll put it under whatever week we're in, that assessment, and I'll let you know that's where I put it. Okay, because they're sort of set up to do that, and then it's really, they're trying to impose an online course, the virtual courses, onto an online template, and it just doesn't work well, but since it's there, we could use it. All right, now we still haven't heard from Jesus, so that's too bad. And we've got, what, about 17 minutes left? Is that right? Yeah. So let's see what we can cover in Chapter 2. Chapter 2 is titled Matrices, as if we haven't already been working with matrices. 2.1 is operations with matrices. And you might say, well, wait, haven't we been doing that? Well, we sort of have, but we haven't hit sort of the theoretical operations. We've been operating with them for sure. The first of these that we're going to do is equality of matrices. Okay? Now, back in section 1.2, use matrices to design, to solve systems of linear equations. This chapter introduces some fundamental matrix theory and further applications of matrices. Okay? Now, here's sort of a difference. Chapter 1 was dealing with solving systems of equations. Guess what? You can use matrices for that for sure, but for lots and lots and lots of other applications. So we're going to be talking about sort of the general theory of matrices, whether it's dealing with a system of equation or not. Okay, so here's a few of the things. Now, well, I can't remember if everybody has a book yet. So I think what I'll do, I'm going to type these couple of things here that leading up to equality of matrices. This isn't exactly to do with it yet, but here's the first one. Okay. It is standard mathematical convention to represent matrices in any one of these three ways. One way is, like we have been doing, an uppercase letter. Okay, this has been the way we've been doing almost exclusively, such as capital A, capital B, B, capital C, something like that. Okay, that's one way to express a matrix. Okay, we've been doing that. Okay, I don't need that much. Okay, the second way we can express a matrix, now I think we've done this as well. Okay, a representative element enclosed in brackets. Goodness gracious, I can't get my fingers on the right keys here. Okay. Okay. Now this is going to be slower to type, and I do have a problem here. Excuse me, I got to sneeze. Is one problem. Hold on. Sorry about that. Okay. Here's the problem. I can't type subscripts, and I need subscripts here. So I'm just going to type it as IJ. Sorry, that didn't come out as an I, did it? IJ. IJ. Okay. Those are supposed to be subscripted. Okay. And for the one up above, that could be BIJ. Now, the IJ should be subscripted. I can't do that in this framework. Okay. Or bracket C IJ. Oh, that's not a J. Okay. Bracket, close bracket. Okay. That's another way we could express a matrix as a representative element within brackets. And the IJ indicates those are the subscripts that correspond to row column. Row column. IJ is the ith row, J is the jth column. Okay. Now, the third way, I'm hoping not to have to type this one out, but the third way is rectangular array of numbers. I probably should have capitalized that. Is that somebody needing something? I just have a ringing in my ear, ding ding, and I don't know why they show up. It's not Jesus coming in, so I don't know what it was. All right, we got 9 minutes. Okay, now I'm not going to do that. We've seen rectangular arrays of numbers. Okay, let me just suggest to you what they look like, if I can get this to expand. Okay. We're not going to do all three, but if it was matrix A here, which we represented by AIJ here, that would be A11, A12, A13, A14, all the way up to A1N, if you had N columns. A21, A22, A23, A224, all the way up to A2N if you had n columns. A31, A33, A32, A33, A34, A3, all the way up to A3N. Then keep going down until you get to AM1, AM2, AM3, AM4, AM5, all the way up to AMN. That's what they do in the book. That's how it looks. That would be for matrix A. If that was matrix B, those would be little b, 1, 1, little b, 1, 2, and so forth. Okay, that's your rectangular array of numbers. Now, as mentioned in chapter 1, the matrices in this text are primarily real matrices. We're not dealing with complex numbers in them. We're only going to use real numbers. That is, the entries are all real numbers. Now, two matrices are equal, this is where we finally get to it, when the corresponding entries are equal. So here's the way we express that mathematically. Two matrices, A, which is, now the short way to represent this is your bracket, and remember I can't do my subscripts, Aij, J, close bracket, and B, which is equal to, open bracket, B, Ij, close bracket, are equal when they have the same size. That's one thing they've got to have, same size, and let's just call it M. I can't do a time sign, so I'm using an X. Hopefully you can see that. M by N. And Aij is equal to Bij for 1. Now I don't think I have a thing. It needs to be less than or equal to. I don't have that key on here, so I'm just going to put less than, but that's a less than or equal to I, which is also less than or equal to M, the little m, okay, and 1 is, and again I don't have an equal, less than or equal to, J is less than or equal to little n, the number of columns. Okay, for every one of them that's got to be true. Now let's stretch that out a little bit so some of the things will make more sense. Oh, it got all of it in there. That's what we mean by equality of matrices. Every corresponding element, every one of them, has to be identically the same. Okay, first they have to be the same size, and then every corresponding element wherever in the matrix has to be the same. Now remember, they can represent the same thing, like 4 halves is the same as 2, okay? Or it could be an X in there, and you just know that the X in this matrix has to correspond to the 17 over in that matrix, or whatever. They just have to be, for them to be equal, every element. So let's do, if we have time, yeah we do, have time, let's do example 1. Here are 4 matrices. Oops, we get back to the draw mode here. Here's matrix A. One, 2, 3, 4. Boy, that's creative, isn't it? Here's matrix B. 1, 3. And a matrix can have just a column. We also call that a column matrix or a column vector. Both of those names work. Here's matrix C, and they name it to be 1, 3. Okay, here's matrix D, and they name it to be 1, 2, X, and 4. Now, my question to you, do you see any two or more matrices that are equal to each other? For instance, is A equal to B? The 1 corresponds to the 1, the 3 corresponds to 3. Are those equal? Yay or nay? No, they're not the same size. No, matrix A is a 2 by 2, matrix B is a 2 by 1. Not the same size, they can't be equal. Well, how about B and C? Now, those have the same numbers and no extra numbers in them. Are those equal? Yay or nay? No. Okay. B is a 2 by 1, whereas C is a 1 by 2. Those are not the same size. Have the same numbers in them, not in the same locations. Okay. So no, they are not equal. Well, how about A and D? Could they be equal? Yay or nay? Yes, they could if, and only if, X is equal to 3. Or X is equal to 9/3, or X is equal to 12/4, or something like that. But basically it has to have a value of 3. But if X is anything other than 3, nope, not equal. 3.000000001, not equal to 3. Okay, so they have to be identically the same value. Okay, now like I said before, this is sometimes called, there it is, a column vector or a column matrix. This is called a row vector or a row matrix. These are called square matrices, 2 by 2 matrices. Okay. Now, they mention something here that is, they just say it and they drop it. They'll come back to it occasionally, but we're really not doing much with it. And this takes this same first matrix we had here and does what they call a partition in this matrix. 1, 3, and they partition this with 2, 4. They draw a little blue line through it. I could do that, but I don't really have. And this partition they call row vector, and usually vectors are given that symbol. In the book they're made bold letters. I can't write bold, but that would be vector A1, row vector A1, 1, 3, which is vector B here, partition with, and here they do the blue line, A2, where A is a vector now, and that vector A2 is 2, 4. Okay? They say that, they leave it, and they don't come back to it again. All right. Now, we're going to lead into matrix addition, subtraction, and scalar multiplication. I don't think we'll get there today. We have 1 minute left, so we'll begin next time, the top of page 41. Okay? Now, let me get something to mark your place. Yuck. Okay. And let's see, any homework exercises here? Yes, you can do either 1 or 3. They're both at Calc Chat, and you can do them there. Don't worry about the rest of those. We'll get those as soon as we finish those matrix addition, subtraction, and scalar multiplication. All right, any questions? Okay. Don't know what happened to Jesus today. Sorry he wasn't here. We've had literally perfect attendance from the very beginning of the term. I know Kira wasn't here the first day because she hadn't added the course yet, but she has now, and ever since when we had perfect attendance until today. Too bad. So Jesus, you blew it. No, sorry. Usually there's a reason. Okay. Any questions? All right, I'm going to stop the sharing if I can find my cursor here, because I'm tired of sharing. And unless you have any questions or comments, we'll end the session. Any? Well, take care of yourself. Have a good weekend, safe weekend. The virus is still out there. Don't get complacent. Plus, I think it's supposed to rain a lot this weekend, so stay inside. Work on research papers. Work on linear algebra, Cal 3, differential equations. You got plenty to work on. So we'll see some of you. No, we'll see you Monday. Some of you Monday. I think all of you Monday and Tuesday as well. So take care. Bye-bye.